Hi everyone, we're going to talk about BFS, which is known as breadth first search or level order traversal. So, BFS is basically a travel technique. We have a binary tree here. So, binary tree is a tree with at most two children. We are going to use this example and understand how BFS works. Okay, so 10 is, so our root node points to the node with value 10. Initially, we have a queue when we implement BFS in an iterative manner, wherein we add the root to the queue. And our stopping condition is that until queue is empty, we are going to keep iterating or keep traversing. Now we see in our next iteration what happens is, in our first iteration, so we've polled 10 and when we poll 10 we are going to check if it has a left child. If yes, we are going to add it, so we've added that here, and we'll check if it has a right child. That is also true, so we have added its right child here, and we can print 10 here or whatever we want to do. So we have basically traversed 10. Okay, in the next iteration we will poll out from the queue again. So this time it is 2. We are going to check if 2 has left child. It's not true. 2 points to 2 as its left child points to null, so we have nothing to add in the queue. 2 will check if 2 has a right child. If yes, we'll add it to the queue, but in this case we don't have a right child for 2, so we are going to add nothing to the queue. Moving on, next up, when we poll from the queue, we poll out 4. Now we are going to check if 4 has a right child. Yeah, it does have, so we've added 6. Now we're going to check if 4 has a right child. So yeah, that is also true, so we've added 5 here, node with the value 5. So now when we poll from the queue, our node with value 6 comes out. We're going to check if it has a left child. It does not have. And we're going to check if it has a right child. No. So we have nothing to add more in the queue. So now when we poll out from the queue again, 5 comes out, node with the value 5. We're going to check if it has a left node. It does not have a left node or a right node either, so we have nothing to add to the queue. And now there is no next iteration because our queue is empty, so we have nothing to traverse more. Yeah, so we'll walk through the code. So here, we've checked if root is null. If it is null, we have returned an empty list of list. Now we have a queue here and we have added root initially to it. Now we are going to iterate until our queue is empty. So what we've done is, we have to store the nodes with the same level in the same list index. So that's why it's list of list. Now what we've done is we've taken the size of the queue, so that would be the size of the elements on that particular level. So we have an empty list here. So now what we do is, from I to 0 till I is less than size, we poll the elements of the queue and we add that to the current level list. Now if the node that we have polled in from the queue has a left child, we'll add it to the queue, and if our current node has a right child, we'll again add the right child to the queue, and we'll keep iterating until the size of the elements of that current level. Once we come out of this for loop, we will add our current level to our result. So that gives us a list of list, and in the end we'll return the result. So this was the code. I hope I was able to explain the concept really nice. Thank you for watching. Bye.